All right, I'm going to walk you guys through a very quick concept. Should be pretty straightforward, almost something that I really don't feel like I need to teach y'all because it's going to be so straightforward in the question. But there's something called tangent line approximations. These are also linear approximations, but essentially using the derivative to be able to calculate a value of a function more easily and just give a really good number that I am close to as we go out. So essentially, what could be happening is I have some curve, something, right? Hello. All right, sorry. So if I have a curve, and it's very easy for me to calculate the tangent line here, what that will allow me to do is if it's very, very difficult or I don't even know a function, to find a point that's just slightly off of it, what I can use is my tangent line to give me about where that value would be. So you'll kind of see how it shows up in a problem like this. This is something that I believe they gave on the AP test on a free response question. But consider an equation f with a derivative given by this. So that's my dy dx, my change in y over the change in the x. That's my slope. Write an equation for the line tangent to the graph of f at 2, -2. So I'm given the point. I'm kind of given the point, given the slope. And use it to approximate f of 2.1. So first thing that I would want to do is write the equation of my line, but I need to find my slope. So dy dx at 2, -2 would be 6 over -4. So that would be -3 over 2. Then I can write my equation of my line. So y plus 2 equals -3 halves times x minus 2. And if I want to use this to approximate f of 2.1, what I can do here, right, is I can say, well, f of 2.1 would be somewhat similar to -3 halves. 2.1 minus 2 minus 2. Right, and I would change that 2.1 minus 2, I'd change that into 1/10, just so I can keep it as a fraction. So this would be -3 halves times 1/10 minus 2, which would be -3 over 20 minus 2. And 2 is, what, 40 over 20? So this would be about -43 over 20. So depending on what kind of function that I have, I don't even know what the function is, but the value should be about -43 over 20 as I go out from that point to -2. But that's essentially all that this is used for, is just using the derivative to give a good approximation of where that function could be based on where the tangent line is going. Obviously, the further out you go, the worse of an approximation this is. But this is going to come into play with things called Taylor polynomials later on. Yeah, so that's it for now. It's just linear approximations using the tangent line to give an approximate value of where that function would be. Okay.